Hey everyone, welcome back to Let's Unbound. Today we are diving into an exciting calculus question. Yes, we are at FRQ 6 of AP Calculus BC 2025 exam. This is a Taylor series based question. We will apply many concepts here like ratio test, we will explore derivatives and also geometric series. So whether you are preparing for an exam or you just love calculus, stay with us. This one's packed with key concept and many smart strategies out there. Let's get started. This is a question. The Taylor series for a function f about x is equal to 4 is given by here sigma n is 1 to infinity x minus 4 whole raised to the power n plus 1 divided by n plus 1 times 3 power n, and which can be expressed like this in expanded form. And it converges to f of x on its interval of convergence. So it converges at the interval of convergence. So interval of convergence is not provided. First part, using ratio test, find the interval of convergence for this and also justify your answer. B part, find the first three non-zero terms and general term of the Taylor series for f dash. So f is a Taylor series given. We need to find three terms and a general term for the Taylor series of f dash, which means the derivative of f about x is equal to 4. So next third is the Taylor series for f dash, that means f prime, described in part B is a geometric series. You will get a geometric series that answers in part B. And for this, for all x in the interval of convergence of the Taylor series f prime, show that f prime of x is this. Right? So in part C, we know the answer. Actually, this is what I need to bring it up. Now part D, it is known that radius of convergence of the Taylor series for f about x is equal to 4 is same as radius of. This fact, everyone knows this, right? Radius of convergence of f is same as f prime. Does the Taylor series for f prime described in part B converge to at x is equal to 8? So we are going to check the Taylor series f prime, which we got in part B. Will it converge to this value at x is equal to 8? Give reason for it answer. So that's all. We will see like all of them are different concepts involved. So 4 concepts in one single question. So let's get started. So first, using ratio test. How to apply ratio test? This is the term you should find first. an plus 1. General term is an, so successor of that. You have to make a ratio. And then you need to like absolute value of it and you apply limit n to infinity. It will give you one expression. First, we need to find that. Right? Let's start. So limit n to infinity modulus an plus 1 by an. So what is your an, by the way? An is the nth term of the series. Like first term is x minus 4 whole square. An is this is x minus 4 whole power n plus 1 divided by n plus 1 into 3 power n. So this is my general term an. An plus 1 means wherever n comes, you replace it with n plus 1. That's it. So limit n tend to infinity. An plus 1 will look like x minus 4 power n plus 1. Now, in terms of n, I will add n plus 1, right? So n plus 1, which is n plus 2. Divided by again n plus 2 times 3 power n plus 1. So we should be careful here. Then times an, actually divided by an, but I will put times and I will write the reciprocal of an. What is reciprocal of an? N plus 1 times 3 power n divided by x minus 4 whole power n plus 1. Right? Now we need to simplify as much as possible, then apply limit n to infinity. So limit n to infinity, x minus 4 n plus 2 and n plus 1. If we cancel, it will be x minus 4 whole power raised to power n. N plus 2, n plus 1, you can't cancel. So they will stay as it is, n plus 1 by n plus 2. 3 power n divided by 3 power n plus 1 means 3 will stay in the denominator. Now, before n only, we will apply limits. Whichever have other known n part, you can take it outside. For example, x minus 4, n plus 2 and n plus 1, if you cancel out, it's x minus 4 power 1. Right? N plus 2 minus n plus 1. N plus 2 minus n minus 1. N and cancel, 2 minus 1 is 1. That's why. Let's change this and now x minus 4 and 3 will come out. They are not dependent on n. So we take this outside. Now we apply limit n to infinity for remaining terms. n plus 1 by n plus 2. Anyways, they are positive, so I didn't use the modulus here. Okay, so now let me continue here. When you apply n tend to infinity, like infinity plus 1, a very big number, add 1, a very big number, add 2, so they're almost closer to 1. So this will be 1 when you apply, right? So x minus 3 by 3 will be your answer. So when you apply limit n tend to infinity, the ratio part an plus 1 by a1, you got this. So now we can set convergence. That's the next part. We applied ratio test and modulus x minus 3, it's x minus 4, actually. X minus 4 by 3 will be less than 1. This is interval of convergence. And how we can simplify this more? So modulus x minus 4 will be less than 3 when you multiply 3 on both sides. And you can even break it down like this. X minus 4 less than negative 3, less than 3 greater than negative 3. Then add 4 on every part, you will get 1 less than x minus 4, minus 4 plus 4 will get cancelled. 3 plus 4 is 7. Got it? So this is what we got. This is the interval of convergence from 1 to 7. And now, one important thing. So we need to apply the test on the endpoints. Okay, so let's test the endpoints 1 and 7, whether I'm getting convergence or divergence. Okay, so this is the thing. So set convergence and find the interval. Now, how to test the endpoint? So just use 1 in your ratio test and the ratio parts that we have taken. Test endpoints. So actually my ratio form is x minus 4. Okay, so we got 1 less than x less than 4. So this is the x minus 4 whole power n plus 1. This is the n term, right? N plus 1 into 3 power n. In place of, actually it's 7. In place of x, I am going to use 1, the endpoints. So 1 minus 4 whole power 3 n plus 1. 1 minus 4 whole power n plus 1. N plus 1 is into 3n, which is negative 3 whole power n plus 1 by 3 power n into n plus 1. So this, my negative 1 whole power n plus 1 you can take, and 3 power n plus 1, split the numerator like this. Then n plus 1 is 3n. This you can simplify and you will get 3 times negative 1 whole power n plus 1 by n plus 1. When you have negative 1 whole power n plus 1, it's an alternating series. When n is odd, like when n plus 1 is odd, you will get negative. When n plus 1 is even, you will get positive. So alternating series, it will be decreasing and limit to 0. So this converges at x is equal to 1. This is testing endpoint at x is equal to 1. So yes, it converges, which means I can include 1 also, right? And next one at x is equal to 7. Same thing, instead 1 I will use 7. 7 minus 4 whole power n plus 1. 3 power n into n plus 1. So this is 3 power n plus 1 by 3 power n into n plus 1. And 3 power n plus 1, if you cancel out, 3 by n plus 1. Okay. So if you have 1 by p something, like 1 by n, it's a harmonic series. 1 by n power p series, correct? So 1 by n, instead I just got shifted 1 units. So this is a shifted harmonic series. Harmonic series always diverges, right? Shifted harmonic series 2. So this is shifted harmonic series. By observing, we found it. And we got this. So hence, this diverges. At x is equal to 7, it diverges. So I can't include 7 in this. But you can include 1. So that's why we are testing endpoints. And the final interval is 1, 7 is interval of convergence. That's simple. Now moving to part B. I hope it's clear. We just applied the ratio test. We got the convergence. But we need to test the endpoints, whether they are included or not. We did. 1 got included, 7, it got excluded. That's it. Right. And moving to part B. Find the first three non-zero terms and the general term of the Taylor series for f dash. The derivative of f about x is equal to 4. Okay, let me write what is f of x. F of x is in general form, n is 1 to infinity, x minus 4 whole power n plus 1 divided by 3 power n into n plus 1. Right? Now differentiate with respect to x, very basic differentiation. Don't touch the n part, which is made up of n only. Okay, this x power n plus 1, how will you differentiate? N plus 1, x power n plus 1 minus 1. So the same thing, instead I have x minus 4. So n plus 1, x minus 4, n plus 1 minus 1 is n. Denominator will be stayed as it is because they are not dependent on x. We are differentiating with respect to x. So that's it. N plus 1 will get cancelled and you got f prime x is x minus 4 the whole power n by 3 power n. That's it. We got the f prime of x, f dash of x something. So first three terms we need to write. Very simple. Just plug in 1, 2, 3, you will get it. So which would be first three terms. First three non-zero terms. Okay. So when you plug in 1, x minus 4 by 3. When you plug in 2, x minus 4 by 4 the whole square by 3 square. X minus 4 by, whole cube, 3 cube. And so on. Or you can write x minus 4 by 3 whole raised to 1. X minus 4 by 3 whole raised square. X minus 4 by 3 whole raised cube. Okay. This is the first three terms. Now, that's it. B part is very simple. Now moving to part C, infinite geometric sum. The Taylor series f prime described in part B is a geometric series. For all x in the interval of convergence of the Taylor series f prime, show that f prime of x is this. Okay, so they said it's an infinite geometric series. Yes, of course we can note that there is a common ratio in between the terms. Like even in the first three terms we can find it. So this is infinite series. We will apply infinite geometric sum rule. Infinite geometric sum. Yes, it's possible. You can find the sum for infinite geometric series. S is equal to A by 1 minus R. So what is A? Your first term, which is, we got it in this, x minus 4 by 3. And the next term is just raising to the power 2. Common ratio you can find from this. R is equal to T2 by T1 or any consecutive terms you can find the ratio of successive divided by preceding. So x minus 4 by 3 square divided by x minus 4 by 3 raised to the power 1 will give you x minus 4 by 3. That's it. So my R is also same thing. Just plug in, you will get the infinite geometric sum. S is equal to A is x minus 4 by 3. Let's do what is 1 minus R here. 1 minus x minus 4 by 3. Like 1, I can write 3 by 3. So 3 minus x plus 4. This is important. 3 minus x, this minus will go plus by 3. So 3 plus 4 is 7 minus x by 3. So this divided by 7 minus x by 3. So x minus 4 by 3 times 3 by 7 minus x. This will get cancelled. X minus 4 by 7 minus x. This is S infinity. Sum of infinite terms of the GP. So yes, we have proved it that S infinity for this f dash of x is this much. Okay, if your series is f dash of x, so finally it will be reduced to this one. And yeah, we have proved it. Right? Very simple. Now we are moving into the last part. It is known that radius of convergence of Taylor series for about x is equal to 4 is same as radius of convergence for the Taylor series f prime about the same center. Does the Taylor series for f prime described in part B converge to this? We know that sum of the series is this much. We just proved, right? But will it converge at x is equal to 8? That is the thing we need to find here, right? So the basic question is, does f prime converge at x is equal to 8? Okay. So radius of convergence is same. So what is the radius of convergence here? It's 3. That is what they have provided in the thing. Here we go. Yes. So the radius of convergence for this is equal to 3. They are same. So the convergence is only valid for like this we need to make x minus 4 is less than 3, right? So this is the radius of convergence. We have got the same expression in our first solving. Here we go, right? So we simplified to find interval of convergence, but this part will say modulus x minus your center less than what? That's this radius of convergence. Okay, hope it's clear. YR is 3. And let's take. So now, also we know x belongs to 1 by 7. So convergence is valid only if this is satisfied. And this implies x will be less than 1. This also we already did, 1 to 7. Right? Now let's see what happens at x is equal to 8. At x is equal to 8, what happens? Let's substitute 8, very simple. Modulus 8 minus 4 is less than 3, which is 4 less than 3 we got. Is that true? No, it's false. So what does it say? Actually 4 greater than 3. If your value is greater than the radius of convergence, which says it lies, x is equal to 8, lies outside the R. Okay, so since x is equal to 8, does not belongs to interval of convergence, the Taylor series for f prime does not converge to f prime 8 because it lies outside the convergence. So final answer you can give no. The Taylor series f prime does not converge to f dash of 8. Or you will say f prime of 8. So when I mean f dash, f prime, they are both same. As x is equal to 8, lies outside the radius of convergence. Or radius of convergence. And that's how we complete this question. I hope all parts are clear here. So if this video helped you in any way, you can like, subscribe and share it with your friends. And also if you have any questions, doubts or suggestions or feedback, you can drop them in comment box. We would love to hear it from you. And thank you so much for learning with us. This is the last FRQ of the AP Calculus BC playlist. If you didn't watch our previous videos, we have many one-shot reviews. All the BC topics have been covered, and also of course AB calculus papers. So you can just go through that, and many 2024 playlists also we have. So if you want to practice, do watch the playlist that we have covered for AP calculus. And let us know about what you want to, what you're expecting from us in next. So until then, we will be giving more content to you. Until then, keep learning and keep practicing. Thank you for learning with us.